Welcome back, everyone. We're going to be solving LeetCode 1539, kth missing positive number. So we're given an array of positive integers which is sorted in strictly increasing order, and an integer k. We want to return the kth positive integer that is missing from this array. So we'll take a look at example 1. We can see that they want the fifth missing positive from this given input array of 2, 3, 4, 7, and 11, and we see that they return 9, right? So that means they give us the numbers that are missing inside this array, and they want the fifth one, right? So 1, 2, 3, 4, 5 would be 9, right? So how can we solve this? We can solve this two ways, by doing a linear scan with a set and by using binary search. So we're going to do both ways in this video. First, let's start off with the linear scan. So we'll say S will be a set of our array because we want to be checking if a certain element is within our set. So we'll say S is going to be equal to a set of our array, and then we'll have a resulting array which we will then index into to get the value that we're looking for. Okay, so to find the missing positives, we will simply just say for I in range length in range 1 to the length of our array, right? But we have to add on k plus 1 onto this. Why? Because take a look at example 2. They give an output of 6 for the second missing positive, right? We can see that this array is already increasing 1, 2, 3, 4, and there's 4 elements. So that means they are extending the array to find the missing positives as well. So we will also have to do that. So in order to make this range work, we have to add k and then add k and then add 1 onto that. So now we can simply check if I, the current number we're at, if that is not in our set, that means we have found a missing positive, and we will just say res.append that number, and then at the end we want to return the kth element. How do we get the kth element? Well, we have to subtract 1 so we can get the index of that kth element. So we will say return res of k minus 1, and that should give us the answer. So we'll run this, submit, and it does work. So let's go back. The runtime of this is going to be O of n, right? And then the space complexity is going to depend on the length of our set and our resulting array. So we can say O of s dot length plus res dot length. Okay, now let's do the binary search way. We'll say time and space. Okay, so like I said, we're going to use binary search. We know binary search always has 2 pointers, so we will say left and right. Left will be equal to 0, right will be equal to the length of our given input array. Now, while left is less than right, we want to find the midpoint. The midpoint is going to be left plus right minus left, and then we will floor divide by 2. Okay, so how do we find missing numbers with binary search? We can say if the number at our midpoint minus the index minus 1, right? So let's say our midpoint is what? So 0 and 1, 2, 3, 4, 5. So what do we have? 0 plus 5, 5. Floor 2 should give us 3, right? Yeah, I think so. Yeah. Let's print out mid real quick. Print mid. And then we'll just break. Okay, so it gives us 2, not 3. Okay, so that would give us a midpoint of 4 for the first iteration. So if we say 4 minus 2, which is m, right? 4 minus 2 is 2, minus 1 is going to be 1. That's going to give us 1, right? 1 is missing in this array, and we can see that that's true here. So we can say if the missing values, right, it's going to give us the number of missing values is what this line is going to do. If the number of missing values is less than k, we're simply going to move our left pointer equal to, it'll now be equal to the midpoint plus 1. Otherwise, we will just decrement our right pointer to be the midpoint now. And then at the end, how do we return the number that we're actually looking for? Well, we can do that by saying return L plus K. So if we run this, it's not working. Why is it not working? Less than K. Right here, break. I have to get rid of the break statement. Okay, so it does work. We'll submit, and it does pass. So again, time complexity, binary search, O of log n. Space complexity is going to be O of 1 in this case. Right, we're not using any extra data structures, so there we go, LeetCode 1539.